Evan is a language teacher and also an R and meetup enthusiast. So one of the cool things about Evan is kind of somewhat similar to when I started at DSR. He had a very clear idea about what he wanted to do, and there was sort of very little ideation or sort of deviation from the initial idea. This is what I want to do, and he just kind of got on and did it. And I think that it's always nice to be in that position in a project because it means that you can get a lot done. So I'll let you guys kind of see for yourselves exactly how much Evan has done. I think he's done a huge amount and a really impressive project. So without further ado, I will give the floor over to Evan.
Thank you so much, Adam. That's very kind of you. So can everyone hear me okay?
I definitely
All
can.
right, good times. So yeah, like Adam said, my name is Evan Simpson, and yeah, starting in 2003, I started teaching English, and I got into language assessment. And once you get into language assessment, you start doing statistics and R and Python, and you go down the rabbit hole. And that led me to DSR. And now I'd like to present my portfolio project, which, as Adam said, is something that arose from my history as a language teacher. So moving on, this is going to be our general outline. I'm going to talk about, give a little bit more of an introduction, talk about the data collection, describe the models that I made, future directions, and then any other questions that we may have. So a long time ago in a country far, far away, I was the language teacher in South Korea. And when I first started teaching, it was my job to find a way to get students to love reading. And the beautiful thing about English language books is that you have quite a few of them that are graded based on language complexity. And so you have Cambridge graded readers, Oxford graded readers, and they're fantastic as far as, like I said earlier, language complexity. Anyone knows the Common European Framework, A1, A2, B1, B2? They work very well for that. All these graded readers are exceptional, except for one little problem is when you then try to recommend books based on age. And one thing that you definitely want to make sure you do is, as a teacher, is not send children home with a book that is wildly inappropriate for how old they are. So that was my challenge, was to create a program that would identify the minimum maturity level required to read a text. And so I did what you normally do, which is you ask, where can I get the data for this? So I asked a friend of mine who's a librarian, and she recommended two different databases. One is EBSCO, and the other one is Common Sense Media. EBSCO requires a university or professional subscription, whereas Common Sense Media is free and publicly available. So I went with Common Sense Media. And as one of our teachers, the AI guru, told us, look at the bleeping data. The very first thing I did was I started looking at Common Sense Media to see if I agreed with their recommendations. And sure enough, they're recommending that Charlie and the Chocolate Factory, you need to be at least 6 years old in order to read that. Okay, that works for me. And then same thing with Harry Potter and the Half-Blood Prince, 11 years old, based on my experience working as an educator with teaching kindergarten, middle school. I said, yeah, that sounds about right. And then moving on to Farewell to Arms, a book about Hemingway's book about love and war. Yeah, that's pretty. It has a lot of adult themes. So 16 years old, I concur. So based on my domain knowledge, I agreed this is definitely a good site to use. So then I created my plan, which was I need to collect the data, I need to clean the data, I need to create the models, interpret the models, and then present. And that's where we're at today. So first step, down the coding rabbit hole, and it's time to go and get all the data. So I scraped all the websites using Beautiful Soup. And this involved me scraping approximately 5,816 web pages. And then once I got all of those one web page for each book, And that, once I was able to do that, I looked at the data and I saw that I had no missing values for these features. The title, description, plot summary, I'm not going to read this all off to you, but all of these features are in different forms. So we have text categories, the date, and then of course the CSM rate, the Common Sense Media rating. The key thing here was to identify which one of these would serve as the target. And of course, it's going to be that rating. That's going to be the key. But the thing is here is I didn't want to treat this like, and I discussed this with Adam and we were in complete lockstep agreement, is that I didn't want to treat the rating as if I didn't want to treat this project like it was a classification problem. I want it to be a regression because a 6-year-old has more in common with either a 5-year-old or a 7-year-old than they do with a 16 or a 17-year-old. Therefore, I wanted to make sure that I took that Common Sense Media rating and I converted it over to a number. And that's what I did. So for example, here, this is a screenshot that they have, sorry, from the CSM website. And you'll see that they have so much information there. In fact, they also provide, this is the example of the plot summary. This is what they say parents need to know. And then they also have a review of the book itself saying like, is it even worth reading? And then they provide more details as well. But once again, that target is right there in the center, the age 9+. So I converted that over to just 9 years old and said that's the minimum age child needs to be in order to read this book. And so once I did that, I then had to look at the distribution of the target. And as you can see, it's a multimodal. The most common age that they recommended was 4. But in fact, when you actually take a look at the distribution in general, you'll see that the average age is 9 years old once you add everything up and divide it. So that is be important to establish a baseline. And so once is 9 years old. So I asked myself, okay, imagine we predict that for every single book you have to be 9 years old. What would the average error be? The absolute error. So for example, if we said that someone had to be 9 years old and it was 10, the error would be 1. If we said that they had to be 9 years old and the actual was 8, it would be 1. So that's the absolute error. And when I calculated the mean absolute error, I found that if just as an incredibly naive model, it would be 3.27. So that's going to serve as our baseline as we evaluate the other models that I created. And so for the very first model, I followed advice and I used XGBoost, known as the king of Kaggle, an ensemble-based method. And sure enough, that required a lot of work because I'm very thankful to the team who went before me because they introduced a lot of these concepts, so I don't have to go into a lot of detail. I had to create a bag of words for the title, the description, the plot summary, the review, and for what parents need to know, all the text columns. I tried just using one of these columns and not concatenating them all together, but every time it just kept giving me the mean. And so I decided, never mind, I'm just going to concatenate all of them, turn it into one long string, and then create a bag of words from that. And then I one hot encoded the type. What type of book is it? Is it going to be fiction or nonfiction? So that was easy. And then I also one hot encoded the genre. So is it fantasy? Is it science fiction? Is it historical fiction? And then I min-max scaled the publication date. And of course, because there's so many hyperparameters to use with XGBoost, I used randomized search in order to try to find the best hyperparameters for this model. And in the end, the train was 1.5 and the test was 1.62. Pretty good. So for example, if the target was 10, it's going on average, it would be about 1.6 off. That's the first model. The next model that I tried was, once again, thank you to the team before me, I did an LSTM. And in order to do that, once again, I took the exact same information as before, but this time I concatenated everything. So I concatenated everything and that turned all that into one string. and then once again used the CSM review as the target. As you can see here, when I say concatenated everything, it would look something similar to this. Whereas at the end, you see it says science fiction, fiction 2017, because it's the genre, the type, and then the date. And then, of course, I tried two different ways with this. One with custom embeddings, and you can see that it had nearly 14 million trainable parameters. And then I did it again with pre-trained embeddings using GloVe. Thank you once again for mentioning that, with the 300 dimensions. And now you notice that there's only 227,000 only 227,000 trainable parameters because the embedding layer is frozen. And therefore, we're not going to be training that. And the results, custom embeddings did quite well. However, the pre-trained embeddings did even better. And that leaves us to the point where the pre-trained embedding on the test is almost 1, which is really good. And then finally, got to answer the question, can you judge a book by its cover? And because I was able to scrape every single one of the covers, for example, just like this, so I just felt the need I had to answer this question. And one issue that I need to point out though is that the same book can have many covers. So for example, here, the Harry Potter book, the Harry Potter series, like Harry Potter and the Philosopher's Stone, it has, in this example, 5 different covers. Therefore, it could be a little bit, in my data set, I only had 1 cover for each book. And so that's just something to keep in mind. Another thing to keep in mind is that all the books that I had, all the covers that I scraped were in different sizes. Some were wider, some were taller. And so therefore, I had to, in order for them to go into the model, I had to standardize them all. And so what I did was I took the mean height and the mean width, and I just rescaled all the book covers so that way they would all fit into the model. The good news, though, is that in order to generate more data, I used image data augmentation, and which means you take the cover, you rotate it slightly, you shear it, you might flip it, you skew it, and you zoom in on it. And this is what it ends up looking like. So for one book, I ended up getting 15 different versions of that same cover, which basically took my data set and multiplied it substantially. And in the end, this is the model. It ended up being incredibly large. And yes, it does train, but the question is why it's bouncing, and the answer is because of the data augmentation. And in the end, the result, the training is 2.69 and the test is 2.5. So for results, we can end up seeing that the concatenated LSTM with pre-trained embeddings is by far the best, and that the computer vision, you can actually judge a book by its cover, but it doesn't give you as much information as these other models. And while this is great, as you know, a few people have told me, life is not a pony show. Life is not a Kaggle competition. And therefore, I had to answer one of the questions that one of my teachers said, which was, if you had all of these categories, if you had all these features, you would also have the target. So in the real world, you would never have all these features and be missing the target. So then I started asking myself, okay, what is the minimal number of features I can use to produce a good model? And I settled on this. I could imagine, yeah, I'd know the title of a book. I would know if it was fiction or not fiction. I would know if it was fantasy, science fiction, and also I would know when it was published. I would know the year that it was published in. So I trained this model. And once again, with custom embeddings, it does quite well. But then, as always, with the pre-trained embeddings, it does even better. And so in the end, these are my final results. And so if I was to go into production, I could imagine using this model that's highlighted over the others. Because realistically, if I was going to do something, which I'm thinking about, Alex and the team before me talking about making a website, and it would ask people enter this information, and then it would give them a rating. Okay. And that's some of the future plans, to add authors to the model, to add page numbers to the model, to add awards to the model. If something is a Booker Prize winner or it won the Newbery Award, you would definitely understand better what age it should be, what age group it would belong to. And then finally, another thought I have is about using multiple inputs. For example, the book covers, that put the book cover image in there, and then also say how big it is, what size the book it is, how thick it is. These are just kind of different ideas that I have. And with that, these are my sources, and I would love for you to keep in touch. So please, the repo you can get now on my GitHub, Educators Are Learners, under the book maturity. This QR code is my LinkedIn. Please know I am currently looking for a job. And so please do get in touch. And then I'd be more than happy to field any questions that you may have.
Everything I have music. Very cool. Really, really nice. Very, very
Thank you,
nice
Adam.
project. Are you planning on registering the web domain educators Python learners and changing over now?
We'll see what happens.
What are your thoughts on the language after working with it for 3 months now? But I know we joke a lot about the R thing, but how do you feel about it now? How has it been for you in the transition? Because I think quite a few other people would be in the situation, right? Knowing how to use R and not Python.
It's just another tool.
Right. Okay.
I mean, the big thing is I've said this countless times, is use R for very specific purposes. You can use Python for anything.
Right. Okay. Cool.
Yeah.
Nice.
So the nice thing about learning Python is you interact with people who are like software developers, and they come at things from a completely different point of view. Whereas if you're talking to our people, you're talking to academics.
Right. Yeah. Yeah. Okay. Cool. I think the syntax is nicer as well. No, I'm joking. Cool. Nice. No, excellent project. I really think it's I really think it's super amazing to see kind of three of these different models tackling the data from very different perspectives and all coming out very well. Very, very impressive project. Cool. Cool.
Thank you.
Oh, I think we actually have a question. Yeah, amazing.
Yay!
Can you scrape the free? Can you scrape the free version of the book from Google Books?
I have tried.
Yeah. It's kind of an interesting question to think, would it generalize to other, Amazon reviews and stuff like that? You probably wouldn't have the target there, but you could, I guess, do predictions on, be interested to see what the intersection was from an Amazon review page with the data set that you have, I guess year, author, genre, perhaps. Yeah. Cool. Good stuff. Okay, so I think we can move on to our next presentation, which is Wenjin.
Thank you very much.
Cool. Wenjin